Hello, my name is Aidan Gosnell, and over this presentation I will be going over Week 2's topic of climate change, but I will be talking about carbon trapping technology. So what is this carbon trapping? Well, in the most basic sense, it's taking carbon dioxide, separating it from the other gases, storing it, or turning it into something else. There have been many forms of carbon trapping, and many forms are used today. So what are these forms? How do they work? And why is this technology paramount for our survival? Throughout this presentation, you will see carbon capturing and storage referred to as CCS. Why is capturing carbon important? Well, as we have learned this semester, humanity kind of messed up. While CO2 is a necessary chemical for life, humankind has released an unprecedented amount of it since the second industrial revolution. With a CO2 concentration level of over 450 parts per million, it's the highest level of CO2 that we can date. Our climate is changing, and in my opinion, it's too late for us to change. We can't just switch to renewable energy and just hope climate change will be solved. Our climate already has the CO2 in its atmosphere to change. So we either reverse what we did, or we learn to survive on our new planet. And I don't think surviving on our new planet is the best option, because many scientists, including the author of The Sixth Extinction, has wrote, climate change is not only our fault, but will bring on the next mass extinction. But there is technology that can save us. Some of it are called carbon scrubbers. Carbon scrubbers are the most popular form of CCS. This technology goes directly into the power plants and filters out the gas from the big old silos, or what they call flue gas. This technology essentially takes the gas, runs it through water filters, and uses organic substances called amines to break away the CO2 from the rest of the gases. Once the CO2 is separated, it is liquefied, compressed, and put into tanks. From there, the carbon can be used in fertilizers, and as also the beverage industry will use it as well. The second method is called Aquifer Storage. This method of CCS still requires carbon scrubbers, but it focuses on the storage part of it. This technology can only be used in new power plants as it relies on groundwater. Groundwater lies a mile to a mile and a half underneath the surface. Much of this groundwater is used for our consumption. However, some of these pockets of water are deeply salinated, or saltwater. These saltwater aquifers aren't sought after by anyone because there's no really use for them. Until now. If we can place new power plants on top of these saltwater aquifers, then we can pump the liquefied CO2 from the scrubbers and put them deep into these caverns. The reason this process works is because when liquefied CO2 meets salt water, the two join together, creating this super dense fluid. So it naturally sinks, and thus will stay underground. Problems with this technology. Carbon capturing and storage, in my opinion, is our saving grace. However, there are many notable problems with this technology that need to be addressed. The first problem is cost. For power plants to install this technology, certain infrastructure changes need to happen. This unfortunately means that many power plants will just need to be rebuilt. This is a big problem, because just in the UK alone, this would force the government to spend $1 billion per plant. The next problem is with aquifer storage systems. Liquids can't be compressed. So at a certain point, a power plant could technically put enough pressure into these aquifers that it would actually break the bedrock above them. This could cause the carbon that's in these caverns to be released back into the atmosphere. It would happen at a slower rate than the process of combustion, but it still kind of negates the whole point of pumping the carbon down there. And the final problem with carbon trapping is that it just doesn't do the thing we want it to. Carbon capturing technology, like scrubbers, can only work in high concentrations of CO2, so they can only work at power plants. However, we need to take CO2 from the atmosphere if we want to reverse climate change. Luckily, there is a solution. 2 years ago at MIT, researchers created a way of carbon trapping that beats all other forms. Discussed earlier was a problem that CCS can't operate at low CO2 concentrations. Well, that's no longer the case. This new carbon capturing technology can work with any concentration level. This is because of how the technology works. It works by running air across battery-like membranes. These membranes have electrochemical plates on them that, when turned on, attract CO2 to bond with them. This allows for atmospheric air to be ran into these membranes, have the CO2 captured, and then let the decarbonated air back into the atmosphere. Then the membranes can be turned off, releasing the bond, allowing for the CO2 to be stored in any way. This technology is really important because it's cheap, relatively, it's easily scaled up because all you need is just to build more membranes, and it allows for a power plant to decide what they want to do with the CO2. This kind of flexibility is what we need if we want CCS to go global. I have a lot of hope in humanity's ability to work hard. Reading about climate science in the 21st century is depressing. It often leaves me feeling hopeless, lost, and apathetic. However, I have hope in humans' ability to be smart, adaptable, and have a strong urge to live. Carbon trapping is a hope for me. It offers a second chance, a chance to save the ecosystems that we've almost completely destroyed. Life on this planet does not die with our mistakes, but human life will if we don't try to save it. We owe it to our planet, we owe it to ourselves to fix our mistakes. If we rise above this challenge, we will become a better civilization. So if you ever feel like it's over, or that we messed up so bad that it's not even worth trying to fix, remember, humanity can fix Earth, because Earth is worth fighting for. And that was my presentation.